So, hey Pontus,
Hello.
I'm Jakub. Could you tell me about how you work with Nao Bots?
Yeah. So in my project, I'm trying to find ways for robots to learn by themselves to use their body. Like, if you imagine a baby when we're small, we get this body with a lot of ways to move around and like, how can we make sense of this? How can we use our body in a nice way to get what I want? And one case for babies, you could learn how to use your voice to get your mom to come to you.
Yeah.
But for humans, a lot of these things could also be like instinct and stuff like this that we're born with. But a lot of the things we need to learn as well. So you have this problem with robots that it's really hard to learn things quickly. The robot should try to learn something. It could be like, how can I control the direction of this torso? Like now it's up. Now it's upside down.
Yeah.
Now it's on the belly, and now it's on the back. And this space, it's only two-dimensional. So how can it learn how to move its body around to control this position? Another thing could be like, how can I control where my hand is? Like now it's over here, but it could reach it in many different ways, and now it's over here. And the idea is for the robot to find one way to reach for every position. It's like if you learn how to do your shoelaces in one way, you will not try to learn another way to do it, because like one is good enough. And this way the robot can learn quite fast. So I've also looked at simulated arms that can have many degrees of freedom. And by degrees of freedom, 1 degree of freedom is like this is one joint, and here's another joint.
Yeah. So that's 2 degrees of freedom within a finger.
Well, yeah, you have like 1, 2, 3, and 4.
Okay.
As well.
Interesting.
So in a lot of classical ways, you would say like, okay, I want your fingertip to be in this position. Give me 5 values that will take your finger in this position. And this is quite tricky, because if you're going to go through all these values, like what values should you take? But another approach, instead of trying to find a perfect answer to a question, is to say like, okay, I want your arm to move to this position, and then you just try out to move somewhere and you end up here. And instead of saying, oh, this is pretty bad, you should be here, but actually you ended up here, instead you could say, wow, that's perfect, this is exactly how we reached this position. And then if you later ask it to go close to here, you can use this and remember it. Yeah. And this is really nice, because it doesn't matter how complicated arm you have. If you have an arm with 1 billion degrees of freedom and you tell it to go here and it ends up here, you still got one correct answer for a position. Let's say you want the robot to be able to learn how to control the torso. So it starts like the rotation, inclination like this. So let's say then, okay, I want you to move to your belly, and then the robot would do something, so it might end up like this, a little bit on the side.
Yeah.
Then you say, wow, that's perfect, this is exactly how you end up a little bit on the side. Yeah. And then from this point, it might learn how to move even a little bit more to the side. And when it's here, finally it might find a position that allows it to actually roll over to the belly. And by allowing it to learn all these things at the same time, the robot can learn very fast. And in my work, I've shown that...
Can I hold it?
Yeah, sure. It's more heavy than you expect.
Yeah, I thought it would be more plasticky. It's like a little baby.
Yeah, I've also tried to see if it can, for example, sit up. Or when it's training, like it's not that I'm telling it to roll over, it's just trying to learn to control this torso.
Yeah.
It's trying to learn to sit up as well, but it's a little bit tricky for it, because to sit up, in this case, it's very heavy in the torso.
Like if I not support it, it just falls back.
Yeah. So it needs to push with the arms to sit up, but the arms are not that strong and it's pretty heavy. I could show that it could sit up a little bit. This is also tricky. When I do the experiments, I need to make it a little bit weaker than it actually is, because if it's using the full force, then it might break its shoulders.
Of the rotors,
yeah, because you see these are plastic. Yeah. I think in newer versions, it's these are made out of metal.
I guess it's much more durable.
It is. Shoulders are also metal, I think, in the new It depends. The neck is probably still. When the robot starts, it have no idea how to move to the belly or something, and it will use whatever body it has.
Yeah.
And to us, you wouldn't maybe use your head to try to sit up, but the robot doesn't know that you're not supposed to use your head to sit up. And actually, this head, it doesn't look like our head because it's kind of like an American football. So it will actually pull with the head like this to
Try
get
to
up of
push
it.
it. Yeah.
Yeah, I can maybe if we see, let's say you are over here. This if you look at the chest now, it's pretty flat, but if it's doing this, it kind of it can move it up a little bit, but this is a little bit dangerous for the robot because the neck is very
so the
fragile.
robot has its sensor in the chest, right?
Yeah, basically it wants to learn to have the chest point in every possible direction.
Yeah.
So like if the chest points like this, it could be like sitting up, it could also be standing up, but because I only wanted to learn one way to do everything, it's much easier to sit up. And now it couldn't really learn to sit up either. I actually did, it managed to sit up in one experiment where I changed the body a little bit. So I added kind of a backpack on the back.
Yeah.
And then it could kind of use this to tip over a little bit easier. But this only works as long as the robot looks exactly as you thought it would look like. So if I change the body a little bit, this pre-programmed behaviors doesn't work anymore because you don't have the same body anymore. And also in my experiments I used some robots that were actually a little bit broken. So for the gears here, the teeth had grinded down, so it couldn't control the leg like this. But because the robot is learning everything from scratch, it will just learn whatever it can do with its body. And like, what does it mean that a robot is broken? By broken, we kind of mean that it doesn't work as it is intended to work. But a robot that learned from scratch, it
has no idea.
No, exactly. Well, like, why would the broken body be worse than the other? And so it will just adapt to whatever body it has. So this is a problem with a lot of the robotics we see today, that you need a programmer to see everything in advance. Like, you need to realize what are the situations the robot will find itself in, and then you have to in advance figure out what should the robot do if it ends up in this situation. But if you have a robot that can learn by itself, then whenever it has a problem, it will try to find the answer to it.
Itself.
Yeah, but it's a very tricky problem, and it's hard to figure out how to do it in a more general way. Yeah.
Brilliant. Thanks. Thank you.
You're welcome.
Brilliant.
Thanks.
So what happened? What happened with the hands? How comes they take that?
So in my experiments, because the robot is moving around, it's a little bit dangerous to the robot to just move around like this, because to learn that you can hurt yourself, at some point you need to hurt yourself. And if you look at a baby, like, they will hurt themselves all the time. But robots, if they break, they break. That, like, they won't heal by themselves. And the fingers of the robot are pretty fragile. So this is more a precaution to stop the hands from
falling apart, breaking
Yeah.
fingers.
Yeah, exactly.
Looks like boxing gloves.